Alright, so another boring video, just for those that are still curious to see the progress. So, to summarize it, been working on intelligence, been working on data, a lot of data, synthetic data, real data. Also been working on getting simulations. So, yeah. So I will show the benchmarks at the end. So I've actually made a lot of progress with benchmarks. Still work in progress, very heavy work in progress. But nevertheless, I think it's gonna be cool. So this is actually one of the scenarios I'm really hoping I can figure out relatively soon, because the cones themselves, they have been like an issue with data like for a long time, because I haven't really added lots of cone information and how LiDAR sees it. So yeah, and so all of the models prior, especially those that are actually trying to avoid something, they have issues with it, because there's curb information, there's barely any cone information, I believe. And overall it's just a hard path to follow. It's not just go forward. Usually models that are stupid in terms of just avoiding stuff or reversing, they could barely pass the test. And you'll see it later in the benchmarks later. But nevertheless, so let me show you the current state. So with this test, it has to follow it precisely, super precisely. Like here, you already see that it crashed and it's going to flip over just because of that. So I count that as a failure. So let's try continue. So far it's doing much better than any previous models prior. Yeah, I don't know, buddy. What are you doing? Oh my god. Come on. Come on. There you go. It figured it out. Awesome. So this is actually a pretty hard test. There's actually another harder test than that, which is so before I was following the points, which made it so, well, extremely. So it's supposed to. So with points, my goal is to have 100% accuracy, but with this, it's complicated. But yeah. Let's see. Yeah, you can see it pretty much fails automatically, especially because it's cones. So let's just compare. So if I was to put something like, well, just put it further away. Well, actually, let's see, because I was saying cones, and now it's not gonna even do anything here. Right. Let's see. Yeah, pretty much crashed, but let's see if I can drive around this. Yeah. Come on. Yeah, you see, it's a little easier for it without cones, especially stuff like this. It just, I should probably place a cone here, because the rule is kind of making it hard. Oh, come on, man. Not supposed to go here, bro. Let's see if I help it. Let's go this way. No, it just wants to go straight forward, because it knows the point is there. Really wants to go there, and yeah. So this is where reinforcement learning would help me a lot, but as I noticed in previous videos before, certainly very problematic. Let's just, there we go. Now let's try and make it complete this. I call it bunker. So the complexity here is, like, you will see there's one entrance, second entrance, and third entrance. Something that can trip the model off, especially when it doesn't have any stuff here. So you can see it will pass it here. Let's try putting it here. Usually, this is like very crazy test examples. It's usually not like that, like at all. You know, in real life scenarios, let's call it so. But you can see the stupidity here again. I'm supposed to reverse all the way here. Yeah, and you see it biasing going forward instead of. So now it's gonna get stuck, I think, unless it finds a way. So I actually think it's going to find a way because there is a bias to the right. So it's actually weight-wise, it's taking left lighter output more into the into account. But as you can see, so it biases forward stuff, but certainly needs to build more understanding of the context. So biasing forward stuff isn't specifically bad. It's just a matter of let's help it here. Yeah, it's just that you need to understand the context more. With current lighter resolution, I believe it's possible to just, you know, not go in here, especially if the point is here. So it's supposed to be much easier. So I think I'm also going to be able to fix this task, hopefully sometime soon. Let's have it go this way. Right. Once it passes this point. Awesome. Now let's try it again. Come on. You don't have to hog the walls, but here you go. Here, this thing is going to crash into the wall. Yeah, usual behavior. Keep scrapping, keep scrapping, but eventually we'll get it. It's just really hard to tell it that don't go close to the wall. Because usually when you go closer to the wall, that's the likelihood of you having some entrance is higher and not missing the turn or whatever. But this is stupid, of course, that it bumps into. Oh, come on, dude. Just go that way. Oh, you're not gonna turn left, are you? Well, this is actually a good example of a memory. So something in its training flipped the switch over and it thought the entrance could be here. We could actually see it on the screen. So it was pointed like this. So as you can see here, it's pretty, you know, rigid wall, but here's like an opening entrance. So obviously lighter resolution plus memory would have helped, but like this is a crazy scenario. This is pretty much intelligence maxing, just helping it figure out, just as an example here. So I believe they just put this away, we'll go forward right away, and here we'll probably start turning again. Yes, because as I noticed before, thinks there's an opening here. Right. Let's probably make it finish here. Good. Now I will show you how it handles this stuff. Let's just put it here. That's supposed to be super easy. This is something that it cannot fail. Like, if it fails, it means it's pretty bad. It just has to ignore all the other stuff. Right, good. Let's just make it finish quick. Oh, did I miss a point? Good. Now, let me show you something. Right, so, yeah, so this is something I've built. So you can actually see, so the current model, some test model, Gen 0 is probably what you saw. So this is actually Gen 3. Just call it Gen 0 is just a starting point. But yeah, so it's like an old video before. It's pretty good. It's actually pretty good in certain scenarios. Usually it's it actually came out to be pretty generalistic. Obviously with memorization problems, blah 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 blah. But nevertheless, so let's just compare stuff. So this is the current stuff. This is the test model I'm having right now. So this is the test model that runs in simulator. So it has much more data and challenges. But it's not real life data, like not from Gmod. It's something very close related to it. So let's just look at, just entrance data metrics. So this is just data that I am including in my training. So this will be forward section, a section where you just need to go forward towards the point, and the smaller the mean error, the better. So obviously this is the best one. So I think this is the second best one. So certainly an improvement over Gen 0 and so an hour version ago, an hour, yeah. So this is avoid, so something where you need to avoid stuff. So 6 degrees here. Certainly is better. I still need to probably so what I'm gonna do is I'm going to rerun all the previous stuff, all the old stuff, because I actually need to look into my older dupes now just to get this Gen 0 information and rerun it, because I believe this is false information. Well, I'm not saying the current version is so much better. It's probably worse in certain scenarios, but being twice worse is, well, yeah, problematic. So yeah, going forward. So elevation difference is usually, some weird mountains and stuff you could see in the other videos prior. 10 degrees, well, also worth rerunning for sure. Because there's a lot of stuff that's been added here. And just having this old data is not correct. So best is to probably look at these and these. Well, probably this too. Yeah, all these four. This one's just for reference pretty much. Weight accuracy is just just the direction forward or reverse. Here we can actually see a regression from this and this. Avoid, just going forward when avoiding stuff. Awesome. Elevation difference, just going forward or reverse, same. So like weight accuracy means going forward or reverse. So here reverse, I know that Gen 0 was actually better because there was so much more data, but unfortunately was a little corrupted. But nevertheless, actually I could fix the data, I just didn't know how. So I just started over and, kind of lost it. But let's go forward. Scenario elevation, go forward. I think it's just some not super weird. So this is actually like a benchmark scenario. So I put in different, data entries and just seeing how it's going to handle them. So this one is just usually, just simple stuff, a simple ramp, simple, race in the ground. The smaller number, the better. So the test model is actually better at it. So get out of the room is actually something intelligence maxing. That's what I call it. So pretty much what you saw with the bunker, but something a little more harder. So imagine the room being a square, and there is a door, and you need to go through that door because there is no other way in. So you don't have to go to the nearest point of that, bearing that you have as an input. You actually need to exit the the building and then go around. So this one was actually the best. Well, considering that it has the most amount of simulational data. But okay, let's go forward. Go over curb. Simple stuff, just a curb, and you need to go over without turning. You just don't need to turn. That's just stupidity benchmark. And an hour ago version was actually better at it. Okay, just go forward. Just there's stuff on the sides. Usually you just need to follow the bearing and that's it. Actually shows whether model has actually learned to ignore objects that you don't have to care about. So actually you can see a regression here. But this model used to be better at following, worse at figuring out stuff. Past the bunker, you could actually see the bunker previously. So simulation 1 is the best. So actually having 8 here is actually a lot. So you could actually imagine 8 degrees. Well, you could think about how many walls you have collided with there. And so forward perfection, so a mean. So that's actually a benchmark that's super important. So imagine, no, actually, let's not use the word imagine here. Just imagine a point somewhere, nothing, just bothers you, anything, and you just need to go to that point. And it kind of shows how stable the system is, how confident it is, and whether it's going to be jerky all over the place. So yeah, so like having 5 degrees here is ridiculous, and even 2 degrees is still pretty bad. Back in a minute we'll be back to Gmod and I'll show you how it actually performs like with this benchmark here. Same with weight accuracy here. Nothing to say here. Simple benchmark just to show, better for me as a developer, just to see if something went wrong with data or I don't know, anything. So open field completion, pretty much open field as much as you can imagine it. No, just, no obstacles, nothing. So just, yeah. Average time to complete 17 seconds. Yeah. Slalom. You'll actually see the pictures here. This is actually very important. So imagine, actually let's show it here. So stuff like this here. So you need to go around this point, pretty much what we saw with the cones. You need to go around and not crash. Just ignore here. Yeah, let's go back. So slalom. Right, so 40% completion rate versus 62% completion rate. So this is with simulation, this is with just better data improvements. So you could actually see the improvements here. So 5% and 7.5, it's just gotten better, way better. Collisions. Yeah, 6% of the time you could see it, like 3 minutes ago. And simulational one is 37. Pretty good. Average time to arrive here, well, as always, collisions. So wall gap, just plain open field with some wall. You need to find the gap and complete it. So actually new model showed better completion rate. You could actually see, right? So all these metrics, they were so much better, but it just learned it. So real time inference problematic. So this is real simulational benchmarks. This is where you need to shine. And the scenarios too. So wall gap, completion rate, collisions, pretty much, yeah. Target behind, simple benchmark. Once again, you just have to, you know, turn around and just go to target, just open field pretty much. Buxton, new benchmark, still work in progress, kind of ignore it now, but yeah. Right, Courier S-Star is pretty much what I told you about. It has to be 100%. So if it's not 100%, then it sucks as a courier. So this system must be on par with the simple A-Star bearing system. If it's not, then it's a failure. So this must be below, you know, 1%. This one should be 99% at least. This actually a really good benchmark here. Just kind of shows the jerkiness here. So the jitter here, max pull from roll. You know, just when one side of the vehicle is on the curb, another one is just on the road. You just see how much it pulls just based from that, how much it impacts it, just to see how much roll impacts stuff. Because it's important for, so roll is super important for bearing gain. So you could actually see it actually learned, even with roll issue, and it just has less jitter from lighter noise. Plus, just learn to be better at it. Inputs, hidden layer 1, hidden layer 2, outputs. Pretty much that's what it is. So all of them are equal here. So you could read this. So here, real data scenarios held out test set. So it is evaluated in the frozen set. So these are excluded from training, and the lower is better. You know, still need to rerun Gen 0. I think it's bullshit, but nevertheless, you could see the light progress going forward. So like blue versus red, which is current. But yeah, certainly there is regressions. I'm not covering it, but you know, just being better and on the simulational and scenario benchmarks is a huge deal already, because it just learns on this stuff. It's not fair. So scenario suit, you could actually see here. Elevation go forward. Let's compare it like the current versus the goodness, an hour ago version. Goodness. So elevation go forward improved, get out of room improved, go over curb worse, just go forward worse. Well, this is terrible actually. Past the bunker slightly worse. So direction, oh my god, no, ignore the text. My time is running out probably. So direction accuracy by scenario, it's just about going forward and reverse. So 100% is the benchmark here. So actually, if you can see the blue one, it actually failed to reverse at all. So the blue one is user default, right? Yes, user default. Let's look at it. So where is it? Reverse. Yeah, you can see 9%. So on that benchmark, obviously it's going to top it because it just doesn't reverse. So pretty much here. Yeah, this actually you can see it here. You can see it here. As I said, Gen 0 was best with reversing, but I'm getting close at it. Very close actually. Blue one, yeah. Funny. So scenario suit, steering area, error by scenario. So this is the scenarios benchmarks. Pretty much, I think we discussed them already. I think. Yes, we did. Direction accuracy by scenario. Did I just repeat the same thing there? Okay. So this is for scenarios for direction accuracy. So this was just the training data, and this is the scenarios. Also, some of the scenarios may have been pre-trained just a little bit, just to see the impact. But yeah, I'll just keep expanding on the scenarios just to make it more accurate overall in general. So let's analyze it here. Get out of room. Yeah, this is intelligence maxing stuff. The user default version was best here. Well, not surprising. Pretty much nothing to see here. Here, you can just see the target versus current. So the dark one, so it says target. So you could look at it. So there's just elevation go forward. You can see it's not that bad here. Get out of room. That's very complicated here. So yeah, you could see just failures here. Rover curve. Still need to expand on that benchmark. Probably just there's a lot of probably noise with all the data here, but nevertheless. Just go forward. This must be the test that it has to pass. But yeah, not perfect. Not perfect. Past the bunker here as again. Darkest target, red is current. So there's actually all the numbers you can see here. You can pause and read them. So this is deviation from ideal in a clear path. So lower is better here. You could actually see. So with the simulational here, it's actually been pretty close here. It's probably the best, kind of. Here, just the more flat it is, the better. So this completion rate for closed loop simulations, so 40 episodes each. Export NetDrive simulator rover from start to waypoint. So this actually real use case scenario. Ignore the boxed in version for now. So 100% slalom, 40%, 72, target behind, courier A star. So there's actually all the simulation trajectories here. You can see just how the simulation kind of looks. So it's actually using bicycle movement here for the rover. Something very close to what it is in Gmod. But here's an example here where it collides. Also need to figure out, maybe I have set up this wrong. Maybe there was actually a wall here that you couldn't cross. So I need to take a look at it. So episode 1, definitely there was a way to win this. Didn't go in. Obviously went pretty good here. Avoided this stuff, but failed here. So I'll probably train on more data like this. And it's also not consistent data, so it's regenerating itself, so it's not always one-to-one. So stuff like this. Good, pretty good here. Target behind, as I said, pretty easy test. Boxed in, timeout, timeout, timeout. Yeah, pretty much. You can see it here, there. Courier A star. Let me just look at stuff here. So you can see the A star points here and how close it follows it. Certainly could be better, but still not close. All models here also just shows how it behaves here. Also, this is funny. I mean, why go here if you could just go there? I mean, makes sense. Absolutely. Here's the steering response as again. So there's a dashed line, and the closer it is, the better. You can see pretty much most of the models follow this path right now. So yeah. here. You could see the 0 here. So the flatter it is, the better. So you could see it -5 and 5. There is some variations here and the drops. So definitely needs to add more sway data in. So current model, what the current model pays attention to. So bigger equals more influence here. So there's 5 levels for lighter. So this is actually so this is ground. So this is builds up. So currently it's using the highest lighter there is for just understanding for weights for it, like decision impact. And you could actually see it very well with the cones. So just having a higher wall just helps it to steer around, obviously. So sector importance here, rear traces now actually, this is really interesting data. It's usually been opposite. It's usually been like very low because rear traces don't impact, but I think that came with rear reversal benchmarks and just overall just learn to rely on the rear trace too. Low multipliers, it's just so there's multipliers for weights, and that multiplier helps against the swaying problem quite a lot, and you'll see it now. So this version history, this is where I added all the benchmarks usually here. So the goal is obviously to get as low as possible. I was getting better and better and better, but I knew that that data wasn't enough because obviously when I tested the model inside the Gmod and gave it actual hard tasks, this is where it failed. So this actually kind of displays what it is. Kind of been stuck at the same place for now, just being better and worse somewhere. But just going forward, it's just slowly improving here, just slowly improving. So I'll probably need like just way more data here and just better benchmarking and simulation here, and I think I can solve this issue. And now let's go back to Gmod here. Right, so what I wanted to show, I forgot. Oh my god, I actually forgot what I wanted to show. Goodness. Let me think. Something I want to show. Let me just look at. I'm sorry for this. Completely unprepared. This is what recording video at 1 a.m. does to you. Oh yes, okay, so let's do it here. Just put it here. So let's put it here. Don't tell me something broke. Oh my god, dude. Where is it? Just update. Right, let's try again. Yeah, you're full of shit. Yeah, sorry about that. I think with the new H-Star it became just less optimized. Let's just make it this way. Wait, you're not gonna run now or something? What's going on here? Right, let's test this out. Just debug it very quick. Oh my god, the usage, yeah, certainly went up. But you can actually see how the model here behaves. Let me just, just stay in front of it. Come on, you have to avoid me. Oh yeah, because I'm a human. Obviously, I made the system, so it just stops. So it actually is super stable here. Let's just try and increase the speed here. So let's just do this. Oh my god, tell me it broke the... Yeah. There you go. You could look at it. And it should be much more stable here. Pretty good here. Let's test it out here. Much higher speed. Let's see how fast it completes. Oh my god, definitely not higher speed, but definitely you could look at, you know, first videos there and it would be much better. So I think for now this is it. Just keep in touch. I'm posting some other stuff you could look at in Ace Discord and the community forum section. I'm just posting stuff there. If you have any ideas, please leave them in the comments down below. And hopefully I'll see you sometime soon. So I'll see you. Bye.